Today we are going to discuss f of x is equals to a over x plus p plus q. This function here is hyperbolic. Hyper means many, bolic means curves. So this function has two curves. It's more than one curve. This function has asymptotes. An asymptote is a point where the graph of a function is not defined. And we indicate an asymptote of a function using a broken line. An asymptote is also a characteristic of some function. Domain is another characteristic. The set of input value or set of x values. The range is set of output values or the y values. So with our asymptote, we can inspect our equation from there, and the generalization is our x plus p equals to 0. So x, you take p to the other side, so our x equals to minus p is our asymptote. And then y is equals to q is the other asymptote. The domain is x, an element of real numbers. And x is not equals to minus p. So in this case we are saying for the domain, this function takes all real values except the asymptotes. Or we can generalize as x an element of real numbers. X is not equals to the x asymptotes. Let's come to the range. Range defines the output. So this one is y, an element of real numbers. Y is not equals to q. Where do we get this q? Is this q that you see here, the asymptote in y. So y, an element of real numbers, y not equals to the y asymptote. Then we wanted to see the effect of q. Remember, the original one we can write is as f of x is equals to 1 over x, where there is no q and there is no p. So we want to see the effect of q. A positive q, it is a shift. It's a shift up. How many units? Q units. And then minus q is a shift down. By how many units? By q units. So this one is known as a translation in y, shifting up and down. That's the effect of q. So if you're having a negative q, shifting downwards, and a positive one, shifting up. What are we shifting up and down? Is the original function of a hyperbola. We have x plus q, x plus p, x minus p. This one here is a shift. Is a shift left. By how many units? P units. So when we are shifting here, you move opposite. You move opposite the sign on p. So for this one here, x minus p, it's a shift right. By how many units? P units. So this sign here shows the direction of the shift. So this one here is the shift is a shift in x, and this one here is a shift in y. So we are shifting up and down, we are shifting left and right. Now, to find this value of a, you need to substitute given coordinates that are on the graph, or in other words, where the graph passes through. We also need to discuss the meaning of a positive a. A positive a, it means your graph of a hyperbola is in the first quadrant and the third quadrant. And for a negative a, it's in the second quadrant and the fourth quadrant. Remember, this is y, this is y, this is x, and this is x. Now, the meaning also of a negative a is that it is a reflection. It's a reflection by the x-axis. So when you are having a function, if you look here, there's two graphs. This one you reflect, this one goes down. So this one is an image of this one. It's a reflection by the x-axis. So when dealing with a hyperbola, one needs to understand that there is shifting up and shifting down, shifting left, shifting right. The characteristics such as the asymptotes respond to the transformation. Let us have an example. Let us have an example. For example, we have our g of x. Let's say our g of x is equals to 1 over x plus 2 plus 1. This plus 1 here is a shift 1 unit up. And this one here is our asymptote. And then x plus 2, our asymptote in x is minus 2. Thank you.